Alright, if you can believe it, this is our third lesson video for section 10.3. My gosh, this has been a long section. So anyway, in the first section we learned how to do percent composition, and we followed this formula, mass of element over mass of compound times 100. In the second lesson video we learned how to do empirical formula by following those 4 steps. In this lesson video we're going to learn how to do molecular formula, and then our section assessment though will kind of review both of these also. Alright, so remember, an empirical formula and molecular formula can be the same, but they can be different. The molecular formula is the actual formula that tells us the number and types of atoms. The empirical formula is the lowest ratio of those. So they can be the same, but they cannot be. So an empirical formula and molecular formula differ by a whole number multiple, so their masses will also differ by the same whole number multiple. So a molecular formula for glucose is C6H12O6. So it has a molar mass of 180 grams per mole when you add those up. If you reduce the formula, so divide each number by 6, because that's the highest they can be reduced by, you get CH2O. That is the empirical formula. When you add up the mass for the empirical formula, you get a 30. So what do they differ by? They differ by 6. I took this formula and divided it by 6 to get the empirical formula. Well, if you do 180 divided by 6, you also get 30. So you may wonder, if, since we're dividing it, why am I calling it a multiplier? Because we're going to be going backwards. We're going to know the empirical formula, but we're trying to get to the molecular formula. So if I know the mass is 30 and I know the multiplier is 6, I can say, okay, well, I multiply my mass by 6, I multiply my formula by 6, and I'll get C6H12O6. So our whole number multiplier, we'll just call it whole number multiplier, I don't have a lot of room over here, equals the mass of the molecular formula, or MF, over mass of the empirical formula. Okay, now if you're in my class, these 2 formulas will be on your formula sheet for any test or quiz, but the steps are not. Okay, so you will need to know the steps by heart. Alright, so it says calculate the molecular formula of a compound whose molar mass is 60 grams per mole. So see, they gave me the mass of the molecular formula right here. It's 60 grams per mole, so I know this part. And it has an empirical formula of CH.N. Well, notice I'm missing the mass of the empirical formula. Well, they gave me the empirical formula, so I can just add up the mass myself. So I'm going to pull my numbers from my periodic table, so you may want to get one of those out. So carbon is 12. Hydrogen is 1, but I'm going to multiply it by 4, and nitrogen is 14. Once I do that, I'm going to get a mass of 30 grams per mole. This is the mass of the empirical formula. Because see, they told me this is the empirical formula. So now I'm ready to get my whole number multiplier. So remember, my whole number multiplier is the mass of the molecular formula, which is 60 grams per mole, divided by the mass of the empirical formula, which is 30 grams per mole. So if you look, my grams per mole cancel and I get a 2. What does the 2 mean? Because a lot of you think this is the answer. Remember, in the last video we talked about what the answer is. It says calculate the molecular formula. That means I need something that looks like CH.N. So what does the 2 mean? The 2 means that's what I'm going to multiply my subscripts by. So it becomes C2H8N2. So once you get your whole number multiplier, you just multiply each subscript by that number. That means to get this empirical formula, everything was reduced by 2. So to get back to the molecular formula, I need to multiply it by 2. So once you get your whole number multiplier, just multiply your formula by that number. And see how much shorter that was than that 3, sometimes 4 steps for empirical formula? This is way easier. Alright, so let's look at a couple more, and then we'll knock out that section assessment, because my gosh, this section has been long. Alright, so we can either look at the top one together, or you can go ahead and try it on your own. So it says find the molecular formula for antifreeze with a molar mass of 62 grams per mole. So this is the mass of my molecular formula. And an empirical formula of CH3O. So I'm missing the mass of my empirical formula. So I just add up. So C is 12, H is 1 times 3, O is 16. At this point, I'm going to kind of assume that you have gotten used to where I'm pulling those numbers from off the periodic table. All right, so CH3O, when I add that up, I get 31 grams per mole. So this is the mass of my empirical formula. So see, now I have both masses. Now a lot of you're going to notice that the math is pretty easy to do in your head. So you probably won't write the math down each time. I don't normally when I'm doing this on my own either, but because I'm teaching it, I will write the whole thing down. So we do mass of our molecular formula, which is 62 grams per mole, over the mass of my empirical formula, which is 31 grams per mole. So the grams per mole cancel, and I'm left with 2 again. So what does the 2 mean? That means I multiply the empirical formula by 2. So instead of CH3O, it becomes C2H6, because it's 3 times 2, O2. And that's it. All right? So if you haven't tried one on your own, definitely try this bottom one. I'll assume you've done that, and let's do it together. So it says, what is the molecular formula for a compound with a molar mass of 90 grams per mole? So there's the mass of my molecular formula. And an empirical formula of CH2O. So let's figure out the mass of that empirical formula. So C is 12, H is 1 times 2, O is 16. So once I add all those together, I get 30 grams per mole. And so this is the mass of my empirical formula. All right, so now I'm ready to get my whole number multiplier, which most of you can probably get in your head at this point, which is fine. You don't have to write this step out if you can do it in your head. All right, so it's the mass of the molecular formula, which is 90 grams per mole, over my mass of my empirical formula, which we calculated was 30 grams per mole. So grams per mole cancel, so I get a multiplier of 3. So I take my empirical formula, CH2O, and I multiply each subscript by 3. So that gives me C3H6O3. All right. Now molecular formula, even though it's one of the easier ones, a lot of you just tend to not know what to do. So remember, this formula is going to be on your formula sheet, but a lot of you just don't realize to use it. Okay, so don't miss something super easy on the test. Make sure you practice this type too. I think that's the problem is you think, oh, it's easy, so you forget to practice it as much as your other ones. So then when you get to the test, you just see, okay, well, there's a 62, like, what do I do with this? And you can't figure out where to go from there. All right, so, whew, thank goodness, that's the last new stuff from this section. So let's knock out this section assessment, because I'm pretty sure that's what's next. Hopefully, all right, we don't want to have to learn anything else at this point. All right, whew, section assessment. So how do you calculate the percent by mass of an element in a compound? Well, the answer to this would just be the formula. The percent composition is the mass of the element over the mass of the compound times 100. Number 2, what information can you obtain from an empirical formula? Well, remember, an empirical formula is the reduced formula. So it will tell us the types of atoms, and it will tell us the lowest ratio of atoms. So I might be able to tell there's going to be 2 times as much hydrogen as there is oxygen, but I might not know how many necessarily. So it will tell me the types of atoms or the elements in the compound, and it will tell me the ratio of the elements in the compound. All right, so number 3, how is the molecular formula of a compound related to its empirical formula? The molecular formula is a whole number multiple of the empirical formula. So in other words, we take the empirical formula, multiply it by a certain whole number, our whole number multiplier, and we can get the molecular formula. Or you could say, if that's kind of wordy, you can say the empirical formula is the reduced form of the molecular formula. All right, so let's knock out some of this math again. So it says calculate the percent composition of calcium acetate. So that was back in the first lesson video of this section. So remember, percent composition is mass of element over mass of compound times 100. Now, I know the question's down here, but I'm going to do some of my work up here too, just for space purposes. Okay, so remember, first we have to write the formula for calcium acetate. So calcium is Ca with a positive 2 charge. Acetate is a polyatomic ion. It's C2H3O2 with a charge. So I need to cross that charge. So I bring my 2 down, but how do I do that on a polyatomic ion? I put it in parentheses. Okay, now to get rid of some numbers, I'm just going to erase my charges so they don't confuse you. All right, so remember, for percent composition, we need masses of each element and mass of the whole compound. All right, so I'm pulling these numbers from the periodic table. So calcium's 40, carbon is going to be 12, but I'm going to multiply it. Remember, this 2 distributes to everything but the C8 because it goes to everything in parentheses. So I actually have 4 carbons. Hydrogen is 1, but I have, remember, we multiply, not add, 6 hydrogens. And oxygen is 16, but I have 4 oxygens, like that. Okay, so make sure you're distributing if you have parentheses. So the mass of the whole thing ends up being 158 grams per mole. But remember, I need each element. Well, calcium's clearly 40. Carbon is 4 times 12, which is 48. Hydrogen 6 times 1, which is 6. Oxygen 16 times 4, which is 64. Okay, so now I have the mass of each element. I have the mass of the whole compound. I have 1, 2, 3, 4 elements: calcium, carbon, hydrogen, oxygen. So unfortunately, I need 4 answers. But hey, it's good practice. All right, so I'm just going to start with calcium. So I'm just going to go way over here. So my percent for calcium, remember, is mass of the element. So for calcium, I have 40 grams per mole over mass of the whole compound, which we decided is 158 times 100. So my grams per mole cancel. So for calcium, I end up getting about 25.3% calcium. Don't forget, number, unit, substance. Saying 25.3% in my class is half off because I don't know what element you're talking about. All right, next I'm going to move on to carbon. So my percent for carbon, remember, it's mass of the element. So for carbon, I have 12 times 4, which is 48. Remember, we talked about how at the end, you should be able to add to get 100. If you plug in 12 instead of 48 for carbon, at the end when you add, you're not going to get 100%. All right, so I have 48 for carbon over mass of the whole compound, which is 158 grams per mole, times 100. So for carbon, I end up getting 30.4%. So number, unit, substance. All right, next I'm going to do hydrogen. So it's mass of the element. So for hydrogen is 6 times 1, which is 6 grams per mole for hydrogen, not 1, over mass of the compound, which is 158 grams per mole total, times 100. And so for hydrogen, I end up getting 3.8%. And then I put my H behind it. So 3.8% H for hydrogen. All right, last one, oxygen. So I do mass of my element. So for oxygen, remember it's 16 times 4, which is 64 grams per mole for oxygen, over the whole compound, which is 158, times 100. So my grams per mole cancel. And so for oxygen, I get 40.5% oxygen. So then what you can do at the end is add up your masses to make sure you get 100%. Now remember what I told you, the most common error is not getting the formula right to begin with. So then, even if you do all your math right and it seems like it's 100%, if it wasn't the correct formula to begin with, you're going to miss it. So remember, if you're having trouble with formulas, go back to Chapter 9 lesson videos. All right, so let's move on. That one was, long. All right. So the next one is just for honors, so we can skip that one. And so then number 6, it says, which of the following molecular formulas are also empirical formulas? Remember, empirical formula is the reduced form. So if it's a molecular and an empirical, that means it cannot be reduced anymore. So see, C5H10O5 can be reduced to CH2O. So it is not an empirical formula also. C6H12O2 can be reduced to C3H6O. They can all be divided by 2. So it is not an empirical formula also. this formula, we have a 55, a 72, 1 for magnesium, 4, and 5. So before you start trying to find multiples, whenever you have a subscript of 1, it cannot be reduced. So this one is a molecular formula, but it is also the empirical formula because we can't reduce it any further. Our last one, we have C12H17ON. So again, we have those subscripts of 1. It cannot be reduced anymore. So this one is also an empirical formula. Woo! Well, section 10.3 was super long. So hopefully you can grasp these 3 concepts because this is from 10.3. The percent composition, empirical formula, and molecular formula. So good luck, and if you have any questions about anything or using your calculator or where I'm getting my numbers from, just ask me in class.